Hello. So here is your second half of 7.1 notes. So last notes, what we talked about what data is, what the categories of data are, and then we practiced putting them into the different categories. We then talked about what actually is a statistic, what are statistics, and then we talked a little bit about what the process of gathering data is, what's the accurate process of gathering data. And we talked a little bit about sampling. We said, okay, we have to create a sample that represents the population, but how do you gather that sample? And that's what sampling is the process of gathering that sample. So we have two different categories of sampling. We have the completely random category of sampling, and random is going to be this entire left-hand side of this page. And then we also have non-random. As a whole, non-random is considered the less accurate sampling technique. It has biases, it has convenience, and it has things that don't truly represent everything that is the population. It only represents a small, inaccurate representation of the population. So let's talk about the 5 different sampling techniques that we have. Before we do that, let's talk about what a sample error is. I'm going to reference that a lot. A sample error, there's a large margin of error here, or there's a small one, or there's a large possibility or probability of a sample error occurring. A sample error is the margin of error between the real population, so the entire amoeba of the population, and the sample. Okay, so that's all that a sample error is that there's a big difference, or there is some sort of difference between the sample that you have and the population. Okay, so sample random, I think it's supposed to be simple random testing. I'm pretty sure, I'll double check. I'm pretty sure that's supposed to be simple random testing. This is the easiest of all. What happens is you have an entire population of something, of elements. What you do is you assign every single element a number. So you categorize each element by having a number associated with it. And then you use a random number generator. To make the sample. So this means that you will have decided how large your sample is from the population. You have a population of 150,000. You want to gather 500. Use a random number generator and just click enter, 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 and it'll give you 500 random numbers, and you go through and find each of those elements that have that number associated, and you pile it on. Okay. There is a large error, or a large margin, or a large probability of sample error, of sample error. So something that's truly random could have, you could go 1, 2, 3, 4 in 150,000 numbers that you could pick from. You could go 1, 2, 3, 4, and that could be random. But that means if you're picking somebody or an element that is 1, 2, 3, 4, you're picking it from a very small neighborhood. And maybe that small neighborhood of elements tend to be lower scores in terms of test scores, or maybe it tends to be students who have the last name that start with C, or maybe it's it really narrows the scope of what we're looking at, and so with that comes a potential skewing of the data. It means that it makes the data seem like we're really heavy in this certain area when we might not actually be that. We can use our calculator to do a random number generator. TI Inspires can go ahead and follow along. If you have a TI-84, while I'm explaining this, go onto your YouTube and look up how to do random number generator on a TI-84. With TI Inspires, all you have to do is press menu, go to probability, and go down to random. You could do number, but number means that it's going to be decimals. So typically we want to do integer. Now, if we wanted to have a random number between 1 and 150,000, and press enter, so I did 1 comma 150,000, it gave me a random number within that category. But now let's say I want 500 numbers that are between 1 and 150,000. So I would go menu 5, 4, 2, 1 comma 150,000. I would do comma again and then do 500. And it will give me 500 numbers. If I scrolled up and went through, it gives me 500 numbers that are randomly generated from that range. So that's a little something that you have available to you if at any point you're like, I just need a random number. Okay, so that's simple random testing. The next type of testing is called stratified random testing, or random sampling. Stratified random sampling is when we divide a population into subpopulations. And then we pull one sample from each population. Keep in mind, when it says one sample, it doesn't just mean one piece of data. It's not like I'm pulling one person out of that subpopulation. It means I'm pulling a certain number of people or items or elements from that subpopulation. If I'm talking about, if I've got the whole upper school as a population, my subpopulation might be, or my stratified, my, what do they call them? My stratum are going to be 6th, 7th, 8th, 9th, 10th, 11th, 12th, right? So we've got all sorts of categories from there, all the grade level categories. And then from those categories, I might pull 10 people, right? And so then you have to use some sort of random pulling or random sampling from each of those populations to gather 10 from each. So your sample is 10 from each of those. It's not just one person from each of those. The issue with this is that you could be oversimplifying and homogenizing. I don't know if that's a word, but you know what I mean. Homogenizing of categories. Is everybody in 12th grade the same? No. And so if you are pulling 10 people from 12th grade to represent your entire 12th grade, you could be oversimplifying what's going on in the 12th grade. So that could be an issue with stratified random sampling. Okay, next one, systematic sampling. Systematic sampling is when you have a population and you know what your sample size is going to be, and you divide your population by sample size. And that's going to give you a number. So for instance, let's say if I have a sample size of 650, or sorry, a population of 659, and my sample size is going to be 20, then K is going to be 659 divided by 20, which is, we're going to round to the nearest whole number, 32, about, okay? So what we've got here is a K of 32. Once you have that, you pick a random number and add K every time. You need to make sure to assign numbers to elements. This is like your simple random testing up top. So you need to assign numbers to all of your elements, whether it's people, whether it's concepts, whether it's tests, whether it's whatever. You have to have a number associated with each of your elements of your population. And then you pick a random number. Let's say we start with 11 and we add 32 every time. What happens is then we say, okay, well, we pick the 11th element, and then we pick the 43rd, and then we pick the 75th, and then we pick the 107th, and then go on. It's random in the fact that the first number we chose was random. And so while there is some sort of non-randomness to this number of 32, the number that we pick at the beginning is what makes it random. This is extremely convenient when you have a process or a formula to follow. It's really convenient. So that's a benefit of this. It's straightforward. It's really easy to detect if you're looking at data and you're like, oh wow, these are really evenly spaced points of data. That's because they did a systematic sampling of all of the points of raw data. And it's evenly distributed. It's all evenly distributed perfectly amongst the population, for better or for worse. Depends on how you've numbered your population. There is still, though, a chance for error, as always. So just be on the lookout for it. Okay, non-random sampling. The first one is convenience sampling, and it's exactly as it sounds. It's selected for convenience. For instance, readily available. Nearby. Ready to participate. Maybe you need to gather information from 20 points of data, and what you've decided to do is hand out a Google form to 20 of your friends. It's easy, it's convenient. They're there, you communicate with them. You can kind of hound them a little bit more and be like, hey, fill out my form that I need to gather data from, because it's convenient to do so, okay? The issue with this, there can be a lot. The main issue with non-random sampling, and especially with convenience sampling, is your sample is less variable. So there's less variety in the sample that you pick than the actual population. The reason is extremes are inconvenient. Convenient. Sample, the extremes of a population are really inconvenient. If you need to sample every house in the region of Novorossiysk, it would be easier to do it in this area. It would be really inconvenient to go down a dirt road and go all the way over there in order to gather data from all points of the Novorossiysk area. So it can be a much more homogenized point of data because you're only gathering from something that's close by. So there's a large sample error with your convenience sampling.